to study data transfer instructions of 8051. Data transfer instructions are widely used in assembly language programming. In this lecture, we are going to study specific data transfer instructions of 8051 microcontroller. So this set of instructions consist of various versions of move instructions, as you can see, various versions of move instruction, then stack instructions. There are only two instructions of stack, push and pop. Only these operations we can perform on stack. That's why two instructions, push and pop. Then exchange instruction. Two different versions of exchange instructions, XCH and XCHD. We will see that in detail. Before starting this lecture, I will introduce you the SFRs and the addresses of the SFRs. To learn more about SFR, you can watch my video and on SFR, which I have uploaded on YouTube. You can watch it anytime. To have more understanding on this topic, first of all go through SFR and then watch this video. Or in this lecture also you can watch the contents of the SFR and you can watch this video also. No problem. So this this image and this image, these two are the SFRs. These two image shows the SFR of 8051. SFR A, B, DPH, DPL, IE, IP, P0, P1, P2, P3, PCON, PSW, SCON, SBUF, SP, SMOD, TCON, TL0, TH0, TL1, TH1. All these are the SFR and these are the respective addresses of the SFR. SFR are located or addressed next to the internal RAM, means after 128 byte. This image I have taken from the Kenneth Ayla book of 8051 microcontroller. Okay, so you can read that book also. You will get to understand more on detail on 8051 microcontroller. So all these are the SFRs and their addresses. You can write the name of the SFR also, or you can write the address of the SFR also. It will give you same effect, no issues. Okay, so in this lecture I will write in some of the examples I will write address or I will write the name. It means the same thing. Okay, so we'll start for the lecture. So this was all about SFR. We'll start for the lecture. First instruction, move A comma RN. So A stands for accumulator and RN stands for register. This instruction is used to move data from register to accumulator. Whatever the contents of the register are moved to accumulator. For example, move R0 comma hash 25. Hash 25 means this is immediate data. This immediate data is moved to R0. Moved to R0. That means R0 is initialized with data 25. That means the register now contains the data 25. Move A comma R0. It means that the contents of the register, which is 25, is moved to the A, that is accumulator. Next instruction, move A comma direct. What is this direct? Or more specifically, we can write it as direct 8. Direct 8 means it is 8-bit data. We are playing with the 8-bit data. So 8-bit data, direct 8-bit data from the direct address is moved to accumulator. For example, move A comma 25H. So 25H is an 8-bit address. It is located in internal RAM of 8051 microcontroller. So data from direct address of 8-bit is moved to accumulator. This square bracket means the contents at the location 25 is moved to accumulator. Next instruction, move A comma at the rate RI. At the rate means the contents at the location or contents at the memory location pointed by the register. So these contents are moved to accumulator. So we'll see one example. Move R0 comma hash 25. Now what is this hash 25? Again, this immediate data is moved to R0. R0 is initialized with 25, hash 25, that immediate value. Now this instruction move a comma at the rate R0. This instruction will move the contents at the location 25 to A. R0 is pointing to the location 25, and at that location whatever the content is, it will be moved to A. Here you can see more specifically I have written A is getting the contents at the location pointed by R0, that is 25. Remember, square bracket means the contents, actual value whatever there will be moved to accumulator. Next instruction, move A comma hash data. So immediate data will be moved to A. Move A comma hash 25. This is very easy because this is of type immediate addressing mode. Next instruction, move Rn comma A. Rn register A accumulator. Now here this is reverse of this instruction. Here the contents from the accumulator will be moved to the register. For example, move A comma hash 25h. In this move A comma hash 25, we have initialized A with hash A with 25, and that content 25 will be moved to the register R0 in next instruction, that is move R0 comma A. Move Rn comma direct. So what is direct? Again, for more specific, this direct is of 8-bit address. 8-bit, that's why I will write it as direct 8. So move Rn comma direct. In this instruction, data will be moved from direct address location to register. So move R0 comma 25 means whatever the content at this location 25, 8-bit contents will be moved to R0. Next instruction, move Rn comma hash data means immediate data will be moved to the register. For example, move R0 comma hash 25. Here the immediate value 25 will be moved to the register R0. Next instruction, before going to the next instruction, I will explain you one thing. So in this 3 instruction, we cannot find the instruction of type move Rn comma Rn. Means in 8051 we cannot have that instruction. Which instruction? Move register to register. We cannot have this instruction in 8051 microcontroller. Okay. To know or to understand more on this topic, you can watch my video on addressing modes of 8051. Remember, all these topics are interlinked. You cannot jump to this video directly. You have to understand first of all the things which I have explained in the previous lectures of addressing mode, and after that only you can understand these things. So for now, remember, we cannot have instruction of type register to register. We cannot move that move from register to register. We can have that same effect with the help of addresses, register comma address, register comma address. You can have that effect with that with the help of that instruction. Next instruction, move direct comma A. Direct 8-bit comma A. In this instruction, data is moved from the accumulator to direct address location, which is of 8-bit. So move, for example, move 25h comma A. Here the contents of the A will be moved to the location 25h. A to the location 25. At the contents will be stored at that address 25h. Next instruction, move direct comma Rn. In this instruction, data will be moved from the register, means register contents will be moved from register to direct address location. For example, first of all, we will initialize R0 content take and register R0. We will initialize R0 with value 16. Now move 25h comma R0. Here, whatever the value of the R0, which is 16, will be moved to the will be moved to the address 25h. Means the contents of 25h will be now 16. Next instruction, move direct comma direct. We can have this instruction in 8051. Direct comma direct means we can move the value from direct address location to direct address location. Direct address location of 8 bit from a from 8 bit. Yes, this will be more accurate. Here also this will be more accurate. So for example, move 25h comma 20. Here the contents of the 20h address 20h will be moved to the 25h. You can see here clearly from 20h to 25h. Next instruction, move direct comma at the rate ri means the contents at the location or contents at the memory location pointed by register will be moved to the direct address of 8 bit. At this location the contents will be moved. For example, again, to simulate this example, we'll take R0 and we'll initialize that R0 with 16 value 16. Now R0 will become 16. Here in this instruction, at the rate R0 means contents at the location 16 will be moved to the 25h. Next instruction, move direct comma hash data. In this instruction, immediate data will be moved to the direct address. For example, move 25h comma hash 16h means value 16 will be moved to the location 25h, means 25h will have content 16. Next instruction, move at the rate ri comma a. In this instruction, contents at accumulator is moved to the memory location pointed by register. For example, we will initialize A with 25h. Now from 25h, initialize with 25. Uh, Now move at the rate r0 comma a. The 25 value which is in the accumulator will be moved to the memory location 25h. Means in memory location pointed by r0 means R0 content will be 25. Next instruction, move at the rate RI comma direct. In this instructions, content at the direct address is of 8 bit will be moved to the memory location pointed by this register. For example, take register R0. Here, whatever the contents at the location 25, in this example, we can see that it is 16 will be moved to the R0. Memory location R0. Value of memory location R0 will be now 16. Next instruction, move at the rate RI comma hash data. Means we can move immediate data to register content register memory location R0 in this example R0. Next instruction, move dptr comma hash data 16 up till until we have seen that data, whatever the data we have seen is of 8 bit. And why we are writing 16 over here? Because dptr register dptr is of 16 bit, so only 16-bit value can be transferred to the DPTR or from access from the DPTR 16-bit value. That's why we are writing it as data 16. So the 16-bit value will be moved to DPTR. This is of immediate addressing type. So for example, move DPTR comma 2000h to write it more accurately. Should write it as hash. So 2000 value 2000 will be moved to the register dptr. Next instruction, move a comma at the rate a plus dptr. Move c. Okay, until we have seen only move, this is a little bit different, which is move c. So what is this move c? First of all, this instruction is of index addressing mode. Index addressing mode. Okay. Here in this instruction, content at the location pointed by dptr and a will be moved to a. Whenever we are dealing with program memory or ROM, and we are accessing data to and from program memory or ROM, we have to write C in front of move. Okay, in front of move. Not in front of move, ahead of move. That is move C. So using move C, we can access the program memory or ROM, or also we can call it as code byte. Everything is one and the same. So for example, move C a comma at the rate a plus dptr. To explain this example in more detail, I will show you. Okay. Uh, First of all, clear the contents of a CLR. Okay. It will clear the content of a, means what will be the value of a now? Well, a value of a will be 0. Next, uh, we'll initialize dptr with something. So move dptr comma hash 2000 h. Okay. Yes. Now we have a as a 0 and dptr as a 2000, means the combined value of a plus dptr will be 2000. Okay. Now the contents at the location 2000, which is in program memory ROM, will be moved to a. This is more specific. Yes. The next instruction, move c a comma at the rate pc. So pc and dptr, both of these are 16-bit registers, and move C is for whenever we want to transfer data to and from the program memory, ROM or code byte, we have to use move C. So this instruction and this instruction, both of these instructions are similar type of instructions. For example, move C a comma at the rate a plus PC. To explain this in more detail, I will write the same thing what I have written over top. CLRA, then move dptr, sorry, not dptr, here PC, we are using PC. So PC comma hash 2000 h, 16-bit address. 2000, why I am writing 2000? Well, 16-bit address to represent a 16-bit address. Understood? Next instruction. Now this is again of different move type, of different move type. Move X. Now X stands for whenever we are accessing data to and from external RAM, or whenever we are dealing with external RAM, we have to use move X. Rest of the things is similar, same. So move X a comma at the rate ri, contents at the memory location pointed by register which is in external RAM will be moved to a. For example, move X a comma at the rate r0. Next instruction, move at the rate dptr. In this instruction, data is moved from external RAM data pointer to a. Next instruction, for example, here for example, move X a comma at the rate dptr. Same. Next, move X at the rate ri comma a. Whenever we want to transfer data to external RAM, from accumulator we have to use this instruction. So move x r0 comma a. Next instruction, move x at the rate. Rest of the things are similar, don't worry about that. Just see the syntax and what is the meaning of that. You have to use this all these instructions in your programming. Whenever you are dealing with internal RAM and doing the program on internal RAM, use only move. And whenever you want to access external RAM or want to do the programming on external RAM, you have to use move x. This is the basic difference, and remember that thing only. So move x at the rate dptr comma a. In this instruction, contents from the a will be moved to the external RAM data pointer pointed by dptr register. Yes, for example, move x at the rate dptr comma a. Now we have finished with the move instructions. Next instruction, push direct. Push and pop. This push and pop are instructions for stack only. Push instruction. This is uh, example of push. Here the contents of the first of all we'll see the example. Push 0fh. Now what is this 0fh? In the starting of the video I have shown you one diagram, SFR, and the addresses of the SFR. So this 0f0 is address of the SFR. Which SFR? It is B. B is having address 0f0. Why we have written 0 front of it? Because the processor should not misunderstood it as a variable. That's why we have written 0 in front of it. So 0f0 is an address of the SFR B that we are using in this example. Push 0f0. What it will do? It will push. It will push contents of the register B onto the stack. Okay, it will push the whatever the contents on the B SFR onto the stack. It will push the contents on the stack. Yeah. Next instruction, I will increase the brightness first of all. Mm, Pop. It indicates the contents of the stack top is moved to the internal RAM location 40H. Remember, stack instructions or stack only works on internal RAM. So pop 40, it will pop the contents of the memory location pointed by 40 from the stack. Okay, it will pop the contents of the stack and the content will be moved to the internal RAM location 40. Next instruction are of exchange instructions. So XCH A comma RN. This instruction is used to exchange the contents of the A and whatever the contents of the register. For example, if contents of the register is 40, then the contents of the accumulator and register R2 will be exchanged. XCH A comma A8. This instruction is used to exchange the contents of the A and address location, 8-bit address location. For example, if 25H address is having value 40, then the A and the accumulator contents of accumulator A and 25H will be exchanged. Next instruction, XCHA comma at the rate RI. This instruction is used to exchange the contents of the memory location pointed by register with accumulator. For example, R2 is if R2 is having value 40, then XCHA comma at the rate R2 will exchange both of this value from A to R2 and R2 to A. Next instruction, XCHD A comma at the rate RI. This instruction is a little bit different. This is XCHD. It will exchange only lower nibble. Remember, this instruction is used to exchange the lower nibble contents of A and the lower nibble contents pointed by the register. So this is little bit big video because These are very important instructions which are used throughout the assembly language programming. So, and the number of instructions also very big, little bit more than of the previous videos of the instructions. So uh, watch this video very carefully. It will clear your concepts and useful in the programming. So for any doubt and query, you can post in the comments. Thank you for watching this video. Dhanyavad.